So I think I'm gonna do a little bit in my notebook first, and then I'll give you the sheet that goes with this. Oh, hold that thought. Morning, Miss Lydia. Hello. Yes. Oh, no problem. Bye. Okay. Oh, yeah, I didn't notice. There's some part of it. I'm still asleep. Okay. So we are going to call this section, which one is it? 12-5. Compound inequalities, and today we're going to focus on the ands. And I'll explain what I even mean by that in a second. There we go. All right. So what in the world even is a compound inequality? So let's define that first real quick. So compound inequalities require two things to be true. There are two types. And inequalities. Where a number must satisfy both requirements. So before I talk about the other type, let me show you some examples. Okay, so here is an example of a compound and inequality. Yeah, go super fast, please. Could you think of a number that does both of these things at the same time? A number that's greater than 3 and less than 10? Of course you can. Give me one of them. Give me a number that's greater than 3 and less than 10. 4, sure. It satisfies both of those requirements at the same time. It's both greater than 3 and it's less than 10. It fits both of them. Okay, so we can write this symbolically. Instead of writing it out in all of these words, that's a lot. It'd be so nice if I could just write it as one inequality. And you can. You ready for this? I'm just going to take my smaller number. So let's write it like this. Written symbolically. Three. And then I'm going to put the X in the middle. And then I'm going to put the 10 over here. This is a little weird to get used to, but once you do, it makes a lot of sense. It's kind of making this sandwich in between 3 and 10. I can have any of the numbers that are in between those two. And if you look at these inequalities sort of one at a time, so if I just cover that part up, that does say, if I read it this way, X is greater than 3. So I want a number that is greater than 3. And then if I look at this side, also I want less than 10. So it's really two inequalities sort of put together to create one single compound inequality. So I have all the numbers greater than 3 and less than 10. That's how I could represent all of them at once. You can give me examples. 4 is just an example of a solution to this, right? So 7 would be another one, but there's an infinite number of numbers that actually work here. It's not just 4, 5, 6, 7, 8, 9. Because couldn't I do 4.5? Right? Wouldn't 4.5 be a number between 3 and 10? Sure. So couldn't I do 4.9999999? Sure. You could go on forever. So this is one nice way to sort of summarize. These are all of the numbers in between 3 and 10. Does that make sense so far? Sort of. So we're going to be focusing on the ands today, but let me tell you what the other types are that we'll be looking at tomorrow. They are called the ors. So here was our first type, the ands. The second type are the ors. Or I guess I shouldn't make it plural. So or inequalities need to only satisfy one of the two requirements. So I shouldn't say requirements. Satisfy one of the two inequalities. Let's say that. Yeah. Sure. So take a look at this example. I'm asking for a number less than 5. You're welcome. Or a number greater than 9. There is no number that fits both of these things at the same time. So it'd be impossible to give me a number that works for both, right? There's no number that's less than 5 and greater than 9. But in an or inequality, they don't both have to be true. I only have to satisfy one of these two things. So I'll give you a number and you tell me if it would be a solution to this or not. You ready? You ready? 12. Yes, because 12 is a number greater than 9. So even though it's not less than 5, it doesn't matter. It only has to work for one of them. Okay, how about 0? Would 0 be a solution? It is, because it is a number that's less than 5. 8. 8 would not, because it doesn't satisfy either one. It's not less than 5 and it's not greater than 9. So 8 definitely doesn't work. Okay. So again, we'll look more at these tomorrow, but I just wanted you to have an overall view. Okay, I have these 2 different types. I have ands and ors. And so yeah. All right, let's focus our attention to these ands and how they kind of work. So ands can be written 2 different ways. So I'm going to give you an example of each different type, and then I'll go through how to solve them. So the first way is as 2 separate inequalities. So something like that might be x plus 2 is greater than 5, and x minus 1 is less than 10. I don't know. So to solve these, it's actually pretty easy because you're just going to solve each one separately and then make sure that there are numbers that do both. All right, so if I look at my first inequality here, what would I do to solve this? X plus 2 is greater than 5. What's my first step? Yeah, just got to minus the 2. So one of my inequalities is that x has to be greater than 3. Okay, fine. Then I come over to the second one and I'm just going to solve this one by itself. So for this one, I just add the 1. So this one, I get a solution pretty easily. Here's the key, and a lot of students forget this part right here. Whenever you are dealing with compound inequalities, your answer has to either say and or. So this is an and problem, so I want all of this is my solution. All of that. Now, I need to ask myself, are there numbers that do both of these at the same time? Are there numbers that are greater than 3 and less than 11? Is that even possible? Sure, yeah. 7, right? 7 is a number greater than 3 and less than 11 at the same time. You can also rewrite this as we talked about it before, sort of making that and sandwich. So if you want, it's a good habit to kind of get into to sort of rewrite it this way. You don't have to, but what if you're taking multiple choice and they show the answers like this? So this can be written as, so you take your smaller of the 2 numbers, which in this case is 3, and then the arrows always kind of point the same way. I've got the x, and then I put my bigger number over here. That is the same exact thing. So you could just write this, or you could write all of this. Samesies, but you got to make sure you have, somehow you're indicating that it's an and, either writing it as an and sandwich or with the word. Okay, so that's one way to write it as 2 separate inequalities. The second way, I'm going to have to flip the page. Everybody have what they need on this side though? Yeah. Okay, so let's flip. The other way that it could be written there we go. So ands can also be written It's one big problem. This is going to look a little weird at first, but then you'll get the hang of it, I promise. So let me make something up here. How about -3 is less than x plus 4 is less than 10. My goal with these is just like any other inequality, I want to get the x by itself. Okay, I always want the x by itself. Right now, see how the x is in the middle? And it's not quite by itself. I got this +4 here. So I just need to get rid of that +4, and then I'll actually be kind of okay. What's weird, and I need everybody to pay attention. You all with me? Everybody? Yeah. Okay. So these are weird because we're used to an equation or an inequality where there's two sides, a left-hand side and a right-hand side. This is different because we really have three pieces. You have a left-hand side, a middle, and a right-hand side. So instead of just subtracting 4 from both sides, I have to subtract 4 from all three sides, the left, the right, and the middle. Okay, so watch everybody. I'm going to -4 to get that by itself, but I got a -4 from everybody, the left, the right, and the middle. What's -3 minus 4? -7. I just bring down the sign. The only thing left in the middle now is just x. And then over here, 10 minus 4 is just 6. That would be my answer. I always like to ask myself, are there actual numbers that fit into this range? Sure, there's plenty of numbers that are bigger than -7 that are less than 6 at the same time. Does that make sense? Let me give you one to try. And then we'll talk about how to graph these. About, oh, I know. Try that one. So just like normal, you want to get the x by itself. So you got to do whatever you would normally do to get the x by itself. You just got to do it to the left, to the middle, and to the right. Yep. Okay, so how am I going to get this x by itself? Look in the middle. I've got 3x, right? How would I get rid of that 3? So, well, I would only -3 if I were adding 3. Well, I'm multiplying right now, right? That's 3 times x. So what do I want to, what's the opposite of multiplying? Yeah, I actually want to divide all of them by 3. You with me? Just like in a normal equation, I'm still just asking okay, what would I normally do? I would normally divide by 3. So everybody's going to get divided by 3. The left, the middle, and the right. So now I've got 15 divided by 3 is just 5. And I just bring these symbols down. The only thing left in the middle now is x. I'm just going to leave the symbols exactly as they are. This I have the or equal to bar under this one. So that just means I need a number that is greater than or equal to 5, but still less than 20. All right, let's talk about how to graph these, and then we'll do maybe one or two that have maybe more than one step in the middle. I think also maybe after lunch, I'm gonna have you guys come up to the board and try some 2 at a time like we used to do. Let's do that. It's been a while. All right, but let's talk about graphing. Okay, so normally, this is not 100% of the time, but like 99% of the time, normally ands get a dot on each end. Well, dot on each number, let's say that. And you shade in between.
Does normally mean that there's another field?
There is a very rare case where they don't make a sandwich like this. If I said, give me a number that's less than 3 and less than 5. Well, if it's got to be less than 3 and less than 5, then isn't it just less than 3? So those are sort of the rare cases, but almost all the time it's going to just be like these. So I'll show you those rare ones probably tomorrow. Okay, so all we have to do, if I wanted to graph this, I'll just bring that same one back down. -7 is less than x is less than 6. So to graph it on my number line, again, I was looking at your quiz and a lot of you are giving me like every single number. I don't need all the numbers. You don't, that takes too much time. I just need the 2 numbers that are in question, right? So in this case, I need a -7 somewhere, and I also need a +6. They should be, the positive should be over here and the negative should be over here, right? And now I need to put a dot on each one. You do still have to abide by closed dot or open dot based on what you have. So just remember, if you have, you're going to use an open dot. If you have one of these and a closed dot, if you have the bar underneath. Right? That's our general rule for all of these. So both of mine do not have the bar underneath. So they're both going to be open. I just put an open dot at -7. I put an open dot at +6. Well, yeah, it does go left and then it goes right. So they just crash into each other. So it really just looks like this bar. And that's it. So I actually don't even have arrows because they just form this bar in between each other. And that is a visual way to see all of the numbers in between -7 and +6. There they all are. So let's try and graph the other one. The 5 is less than or equal to x is less than 20. So again, you don't need to number all the numbers from 0 to 20. I don't need them. Just give me the 5 and give me the 20. So go ahead and put the dots you think belong and shade where you think you're supposed to shade. And we'll check in just a second and see if that works out.
Are we gonna do like graphic order?
Good idea. They are. When it's these nice, easy ones, you're literally just putting the 2 dots and shading in between. Does it get trickier than that? It can a little bit. Okay, what kind of a dot should I be putting on the 5? Closed, because that one does have the bar underneath. So this one should be a closed dot. What kind of a dot at 20? That one's open. And then I do want all the numbers in between them, bigger than 5, less than 20. So I just make this bar in between. That's it. All right, I'm going to step it up a little bit of a notch. Let's try one that has more than one step in the middle. Let's try something like, okay. Oh, you know what? Can I change one thing? I want to change. Shoot. I think I want to change 2 things. I'm so sorry. Change that -5. Let's make that a -10. I just want the numbers to work out a certain way. And then this 10, let's change it to a 30. Sorry. Okay. Double check that you have it the same way I have it now, otherwise you'll be all confused. Okay, everybody ready? All right, so our goal is to get the x by itself in the middle. If this were a normal equation, right? Forget that I have 3 pieces. Just look at this 5x minus 10. 5x minus 10. What do you normally do first to try and get that x by itself? I would add 10 first, right? We always do order of operations backwards. So if there's add, subtract, I'm going to do that first, and then I'll undo any multiplication or division. So I want to add 10. Is everybody watching? You watching? You all watching? My students, not Miss Wilson's. You guys don't have to watch me. The rest of you do. So we're going to add 10, but remember, you got to add 10 to all 3 parts. So I'm going to add 10 to the middle, and those will cancel. I have to add 10 to the left, and I have to add 10 to the right. All of those places I'm going to add 10 to. So what's -40 plus 10? -30. Now in the middle, because these 10s are going to cancel, I just have 5x that's left. And then over here, 30 plus 10 is 40. And now I just have to do it again because I'm still trying to get x completely by itself. This one was just a 2-step process. So what should my next thing be that I do? Divide by 5, right? I still want that x by itself, so I got to get rid of that 5. So let's undo multiplying by 5 by dividing by 5. So again, I do all 3 parts. Everybody's going to get divided by 5. Go ahead and try and graph that solution. So put your 2 dots on -6 and 8, whatever you think they should be. Then I want to do one more example and then pause there. Okay, what kind of a dot at -6? Yes. Also open at 8, right? And then all I have to do is shade in between them. So I just have this bar between -6 and +8. Make sure they're both open. That's not so bad, is it? No. All right, I'm gonna give you one more example that's a little weird. Something's gonna happen here, but you know what? We'll figure it out. Okay, we're gonna try this. Bless you. Okay, what should my first step be?
6.
Yes, let's -6 from the middle, from the left, from the right. -4 minus 6 is going to get me a -10. In the middle, these 6's are going to cancel each other out. So all I'm left with is -2x. And then over here, 12 minus 6 is just 6. All right, now what do I do? Right, and everybody, what happens when you divide by a negative? The symbol's got to flip over. When we are dealing in inequalities, anytime you multiply or divide both sides, in this case, all three sides, by a negative, you got to flip the inequality symbol over. There's two inequality symbols. They're both going to get flipped here. So everybody, please watch. Watch this magic. I'm going to divide everybody by a -2. Left, right, and center. Watch what happens now. This is now a +5. That symbol has to flip around. I have just x left in the middle. And then again, I divided by a negative on this side too. So that one flips around and I get a -3 over there. Can you leave your answer like this? You can. I personally don't like it because I always want this number to be the smaller number. And that's not the case here. So just like before, remember last week, like when the variable was on the wrong side, we just flopped it over. We can do the same thing here. You don't have to. This is perfectly fine. You could leave it like this. But if you were taking a multiple choice test and you didn't see this as an answer, they might have flopped the whole thing over. So that's what I'm going to do. I literally just take it all like a mirror image. -3. And then notice the mouth is eating the x. So I make sure the mouth is still eating the x. Over here, the mouth is eating the 5. It's still eating the 5. So those two things are 100% the same. But this is set up in the way kind of like how all the other ones are. Your smaller number, your bigger number. So I'm going to put the dot on each of them and just shade in between. You still do that over here, but you'd have to be careful on your number line. I can't tell you how many times kids will try and put the 5 here and then the -3 here. That's not how number lines work, right? The negatives always go on the side. And the positives go on the side. But now I'm set up. What kind of a dot should I put at the -3? Open. And then at the 5, it's going to be closed. And I shade in between. And there we have it. Any questions so far? So I think this is a good place for us to pause for lunch. When we get back, we'll try some more. I'll have you guys do them on the board, like I said. And go from there, okay? Okay,